For this video, we are going to be discussing distance. So first off, maybe we should start by describing exactly what distance is. Distance is simply the length of a segment that exists between any 2 points. So if I have these 2 points, A and B, the distance is just the length of this segment drawn between the 2 points. And so we find distance by using the distance formula. Okay? So the distance formula is this crazy looking radical here. It's the square root of the difference of the x coordinates squared plus the difference of the y coordinates squared. And I'm going to show you something here that's going to make this distance formula make a lot of sense to you. So if I take a look here, I've got this segment here between these 2 points. And what I'm going to do is I'm going to find the distance. But I want to show you how the distance formula is derived. So one thing I could do here, draw these 2 dotted lines in. Okay, so I've got this dotted line and I've got this dotted line. One thing you might notice is that I've got here a right triangle. Right? And if you remember back, you've learned before the Pythagorean theorem, a squared plus b squared equals c squared. That's the Pythagorean theorem. That's saying that if I call this A, and I call this B, and I call this C, I can use this right here to figure out how long this segment C is. So how do I do that? Well, I square A and B, and then I take the square, and then I add them together and take the square root. Or another way of doing that is if I want to figure out what C is, I just take the square root of both sides, and I get the square root of a squared plus b squared equals c. Okay? So this is the Pythagorean theorem solved for c. Well, if I'm looking in the coordinate plane, I can kind of rewrite these things. If I call this x1 and this y1, and I call this x2, and I call this y2, well, isn't this line segment here, the distance of this line segment is just my x2 value minus my x1 value. It's just this straight line here. So to figure out how long this is, well, it's just 4 minus negative 2, which is 6. I can kind of count that. 1, 2, 3, 4, 5. Oh, sorry, these are halves. 1, 2, 3, 4, 5, 6. All right, so instead of writing a squared, I can call this x2 minus x1. That tells me how long this side is. So instead of a squared, I can just make this x2 minus x1 squared. Similarly, instead of b squared, this vertical distance here is y2 minus y1. So plus y2 minus y1 squared. All right. So, well, if you notice, this is just the distance formula. It's bad handwriting, but this is just the distance formula written out as substitution for the Pythagorean theorem. Instead of C, I can just put that as D for distance. So you can see here that the distance formula is just the Pythagorean theorem. That's all it is. Because a segment between any 2 points on the coordinate plane can be thought of as the hypotenuse of a right triangle. All right? So that's where the distance formula comes from. So if I want to find the distance of this segment, I just go, well, I've got my y1 or x1 and x2. I go x2 is 4 minus x1, which is negative 2, squared, plus y2, which is 3, minus y1, which is 1, squared, equals d. This is 6 squared. This is 2 squared equals d. And 6 squared is 36. Plus 2 squared is 4. All right. So I get the square root of 40 equals d. Now the square root of 40 is an irrational number, so I don't want to turn it into a decimal, but what I do want to do is, if I remember back to algebra, I want to simplify this radical. So I want to think, what's a perfect square that goes into 40? Well, 40, that's 4 times 10, so 4 and 10. 10 doesn't have any perfect square factors. Square root of 4 is 2, so the square root of 40 is the same thing as 2 times the square root of 10. That right there is the distance between these 2 points. Okay, this is just some review of algebra for you. So you can see that the distance formula is simply plugging the numbers in to our formula. Now, the nice thing about this is it doesn't really matter what you put in for x1 and x2. I could have just done, well, here, I'll just show you. Another way we could have done this is I could have gone, instead of 4 minus negative 2, I could have done negative 2 minus 4 squared plus 1 minus 3 squared. Then I'd get negative 6 squared plus negative 2 squared. But negative 6 squared is the same thing as 6 squared, that's 36. And negative 2 squared is the same thing as 2 squared, that's 4. So I still end up with square root of 40, or 2 square root of 10. So that's all we have to do, is plug our numbers into this distance formula, which comes from the Pythagorean theorem. So let's do some examples and see how it works. So example 1 says, find the distance between the points 3, 5, and n, which is at 7, 8. So why don't you go ahead and pause the video and try this one, and then we'll go over it. So now that you've tried this, let's go ahead and solve this problem. So the first thing we want to do is we want to decide what's x1 and what's y1, or what's x1 and y1 and what's x2 and y2. I'm going to go ahead and just call this x1, y1, x2, y2. All right, so now we're just going to plug these into this formula. Square root of 7 minus 3 squared plus 8 minus 5 squared. 7 minus 3, that's 4 squared. 8 minus 5 is 3 squared. This is the square root of 16 plus 9. And now we get the square root of 25, and that is 5. So the distance between those 2 points is simply 5. All right, so that's all we did. Took our points, plugged them into the distance formula. You could have done this the other way around and done 3 minus 7 and 5 minus 8. Wouldn't really make a difference. You would still end up with an answer of 5. So let's take a look at a word problem that uses the distance formula. It says Steve starts out at his house and walks 15 blocks north, then turns and walks 8 blocks west. How far from home is Steve? Well, let's think about this. If I call this point right here Steve's house, okay, so that's Steve's house. It says that he goes 15 blocks north, so let's draw a line up. Okay, he walks 15 blocks north, and then he walks 8 blocks, well, sorry, I went east. 8 blocks west. All right, and stops. Okay, there's Steve. The question asks, how far from home is he? Well, this how far from home, that's his distance in a straight line, so that's this dotted line here. So he's gone 15 blocks north, and he's gone 8 blocks west. Well, to solve this, I don't even have to do all of the work of finding out points and plugging them into the Pythagorean theorem. 15, that's my y2 minus y1. That's my vertical change. And 8, that's my x2 minus x1. That's my horizontal change. So to find the distance, I just plug those into our distance formula. 8 squared plus 15 squared. So trying to find the square root of 8 squared plus 15 squared. That's 64 plus 225. So now we're talking the square root of 289, which is 17 blocks. So Steve is just 17 blocks from home. So that's all we're doing, is we're simply taking the numbers here, plugging them into our distance formula, which is the same thing as the Pythagorean theorem, and solving for our missing side. All right, so now you know everything there is to know about the distance formula. Your try-it problem for tonight is to find the distance between points J and K.